The National Centre for Nuclear Research is the largest research institute in Poland. As the name suggests, it addresses the issues of research in nuclear physics and related areas. The research areas include radioisotope production, manufacturing of radiation detection devices, as well as pure science in the form of research in the physics of elementary particles. We are standing in front of the Świerk Computer Center facility, where the main computer systems of the National Center of Nuclear Research are located. This is the computing infrastructure used mainly for power engineering, including nuclear power engineering. Now, we are in our main server room, which is the heart of our supercomputer. The supercomputer was designed as part of the Świerk Computing Center project. Our servers need a great amount of power for proper operation, which directly translates into the amount of heat they generate. Each server rack generates up to 50 kilowatts. Therefore, we needed a cooling solution that would be not only reliable, but also very efficient. We have chosen the Rittal chilled water cooling system for our server room. The system works in a similar way to a standing household fridge. Compressors chill water down to about 15 degrees Celsius. Then the chilled water is transported to specialized exchangers located between the server racks and cools down the servers. To improve reliability, all components of the cooling system are redundant. 2 chillers, 2 independent water circuits, and 2 heat exchangers for each server rack. On the roof there are 2 Rittal chiller units with cooling capacity of 406 kilowatts each. Those are cutting-edge units that switch to the free cooling mode automatically whenever ambient conditions permit, which is when the temperature is sufficiently low. Free cooling doesn't require using the compressors. The Świerk Computing Center of the National Center for Nuclear Research hosts one of the currently most powerful computers in the world. We are currently in the room where the power is distributed to our supercomputer. This is over 1 megawatt, which is an extreme amount of electrical power. The power used for computing generates the heat which must be transferred away. As a result, a very high-tech and efficient cooling system is required. This is why we use the Rittal solution. It is the Rematrix 5 system. The Rittal system is unique because it makes it possible to dissipate such a great amount of power through a narrow in-row module. But, more importantly, it guarantees redundancy, which means other modules take over the functionality of the entire system if one of the modules fails. Thanks to the Rittal cooling system, we can do efficient nuclear medicine-related computing. For example, designing a new generation equipment for early detection of cancer, and for power network modeling to optimize its design in order to make power transmission as cost-effective and as fail-proof as possible. Thanks to the Rittal solution, we can achieve a high-density computing power, which makes it possible for the supercomputer to achieve higher efficiency.